Very good morning. In the previous lecture, I have discussed the differential length in Cartesian coordinate system, differential length in cylindrical coordinate system, and differential length in spherical coordinate system. I also discussed the differential area in this three coordinate system and differential volume in all the three coordinate system. In today's lecture, I am going to discuss the very important term line integral, surface integral, and volume integrals. So, first I will discuss line integral. Line means path along a curve in space. A specified path is there along the space. In electromagnetics, we deal with various vector fields like electric field, magnetic field. If you consider such electric field as shown in figure, this say a line or a vector AB is present in the field, is present in the vector field E, and if we are trying to calculate the line integral, then line integral is a product of length of vector and the component of vector field and the component of this vector field E along the path, along the line. And the line integral of vector field E along the path L is given as integration from A to B vector E dot vector dl, where dl is differential length. So this is the product of the length of the vector and component of the field and the component of the field along this vector, or you can say this line. At every point of the line. This is written as line integral is equal to this one. So towards the line, if you have a vector field A, then the line integral of vector field A towards the line L is the line integral of vector A. If A dot dl means line integral written simply in this form, and then this line integral is open contour, and the line integral is written in this form. Here the line integral or the path is closed, so we can call this a closed contour. close contour. So the line integral of a vector field E, if you consider this figure, then the line integral is equal to E dot dl, and this is equal to E cos theta dl from A to B. Here the path is not closed, so we can say that this line integral is open contour. Line integral in open contour. In another words, we can also say that the dot product of vector with a specified C or the path L, it is the tangential integral of tangential component along this path, along the given path. Then we have a surface integral very important question: what are the physical significance of line integrations in electromagnetics? What is the physical significance of line integrations in electromagnetics? If you're trying to calculate the work, in electromagnetics, it is based on the concept of integrations. It is based on the concept of line integrations. Suppose we are moving a charge in electric field. Then the work done is calculated as work done W is equal to Q charge. We are trying to move charge Q in a given field, and this is equal to Q E dot dl, line integral into the charge. Basically, the line integration is required when we want to calculate the component. Basically, the line integral is required when we are trying to calculate the component or the value of any vector field along the given vector path, as you can say in Ampere's law. As you can say Ampere's law. So the physical significance of the line integral is this. Then surface integral. Suppose we have a surface. This is the surface, and this is small area ds. We already discussed in previous lecture. Small area or differential area is a vector quantity. So we have magnitude of this vector and the directions. So directions of this vector is perpendicular to this vector field, perpendicular to this area. Suppose this is AN, and the electric field is along these directions, the directions of electric field. Suppose the directions of electric field is along this. This is closed surface, surface S. So gamma surface integral is equal to A dot ds, A dot ds integral, then integrations of A dot ds. Here the surface is closed in nature, here the surface is not closed. A is a vector field. A is vector field. Here I have considered electric fields. So in place of A, you may write electric field. Here A, vector A is a vector field. Here A is a vector field which is continuous in a region containing this surface S, and which is continuous, this vector field is continuous in region containing the smooth surface S. Or we can also say the flux through the area A is given as psi is equal to A dot integrations of A dot ds, or psi is equal to closed integral of A dot ds. So this is the flux through A. This is flux through vector field A. This is flux through vector field A. Then we have volume integral. Suppose rho v is a scalar quantity, density is a scalar quantity, So the volume integral can be calculated as rho v or volume v, rho v dv. This is all about line integral, surface integral and volume integrals. Then there is very important operator. This is the symbol of del operator. This is simple an operator. Or we can say this is a vector differential operator. Or sometimes we can say gradient operator. This del is given as dou upon dou x. In Cartesian system, I am writing del dou upon dou y ay, dou upon dou z az. Here del operator is not a vector itself.